Hey guys, how's it going? So today we're going to be talking about measures of central tendency, which allow statisticians to basically describe the middle or the center of any distribution or data set. So let's go ahead and get started. So here we have two measures of central tendency, the two most important ones that most books, professors, and anybody really cares about. We have the mean and the median. So knowing the measures of center and spread can let you compare one distribution to another. So we're not quite fully there yet because we don't know what spread is, but once we get there, we'll kind of be able to see how distributions compare to one another. So let's go and start off with the mean. The mean is essentially the average. And so back in maybe grade school, elementary school, kindergarten, whenever you learn this, at some point you probably learned that the average is essentially you add everything up divided by how many observations there are. So the same rules apply in statistics. It's just the formula's a little crazier because we're in college now. So here we have our sample mean, and that's just represented by what's called x bar. And so that's that little guy right there. And then we have 1 over n. What is n? So n is essentially our sample size, which I wrote there on the right hand side. So our sample size is just however many observations there are. Then we also have this crazy looking thing called the summation, and all it basically tells us to do is add up everything. And what's everything? It's referring to, in particular, this little xi. What's an xi? Xi is just each individual observation. So, moral of the story, the more complicated version way of saying add up everything divided by the total number of observations, as we learned probably back in grade school. Now the median is not really the average. Essentially what it is the midpoint. And we're talking about the midpoint when the data is ordered. So you can't just get a data set and look for the midpoint and that's it. That data set has to be in order from low to high in order for you to be able to find the median. And now another thing too is if the data set's really big, sometimes kind of finding the midpoint is not as simple. So one of the easiest way to do it is that you look up for the n plus 1 over 2. When I say, I mean whatever number that ends up being. If it's 8, it's the 8th observation, right? Observation, again, when it's in order, right? So both of these conditions are requiring that the data is placed in order from low to high. So let's go ahead and just use those applications and try some practice problems out. So we have find the mean and median for the following data set. So here we have 7 numbers. And let's go ahead and start off with the median. So the median, what is the first step that's required in order to find that? Right, so first things first, we got to put the data in order. So let's go ahead and start off with, we got 12, 15, 18, 18, 20, 24, and 32. So now, like I said earlier, you can go ahead and your roundabout way find the midpoint of any data set. The way we do that is just cross it one at a time. Left, right, until you left with 1. So here we have our median. Now again, what's the other way? It's n plus 1 over 2 observation. So n plus 1 over 2, what's our n? Our n is our sample size, right? So how many observations do we have total? We have 7. 7 plus 1 over 2. And the reason why I put it in parentheses is that when you put this in your calculator, if you just put 7 plus 1 divided by 2, it wouldn't give you the right answer. So first you have to tell the calculator 7 plus 1, add that up, and then divide that by 2. So that's going to give us 4, right? Because it's just 8 over 2. So that tells me it's the 4th observation. Does that make sense? So now we know it's the 4th observation, so we just count. We're going to end up with the same thing, right? 1, 2, 3, 4. Hey, crazy, it's 18. So our median is 18. And now let's go ahead and get our average, our sample mean. So x bar is 1 over n, which our n in this case, let's go ahead and just plug in the number, why not? What was our n again? 7, right? So 1 over 7 times, and then what are we adding up? Those xi's represent each observation, right? So let's go ahead and add those up. We got 12, 18, 32, 15, 18, 20, and 24. Now, would it have made a difference if I used the ordered data set? No, because the only time you need to put it in order is for the median. The mean is irrelevant whether it's in order or not. So let's go ahead and plug in those numbers. And like I said, I'm using these parentheses because if you had just put in 12 plus 18 plus 24 divided by 7, it's not going to give you the right answer. So first off, let's go ahead and put the parentheses around everything to make sure that the calculator knows to add first and then divide by the 7. And so what we end up with is 29.875. No, we don't. We end up with 17. And so what we end up with is 17. So now we have our mean, our median, right? Let's go ahead and write down that our median was 18. They're very close, right? Which we would kind of would like. But let's go ahead and check out another data set and see what happens. So let's find the median again. What's our first step for the median? Put it in order, right? So let's put it in order. We got 12, 15, 18, 18, 20, 24, and 32. Oh, and 100. Whoop, look at that crazy one. So to find the median, again, you can do it your roundabout way, just left, right, as we get closer and closer to the center. So here we go. 1, 1, 2, 2, 3, 3. Oh, crazy. We're somewhere in the middle between these two, right? So what we do is just get the average. What's the middle, right? What's the average of those two? So median is then going to be 18 plus 20 over 2. Does that make sense? So remember that 18 plus 20 is in parentheses just to tell the calculator that it adds everything on top first and then divide by 2. So 18 plus 20 over 2, finding the average is essentially 19. Cool story, bro. So now you get the median. Let's go ahead and get the average. So the average, instead of 1 over 7, we have now how many observations? 8, right? So we got 1 over 8 times, and now let's go ahead and add everything up. So we got 12, 18, 32, 15, 18, 20, 24, and 100. So once we do all that, we end up with 29.875. And I go ahead and count these calculations again ahead of time so that we save some time. So we get 29.875 is our mean. Our median is 19. Cool. So we know how to calculate them now. Now what do they represent? How can we use them? How can they tell us a little bit about the data? So here's where we talk about the mean versus the median real quick. So measures can be robust or resistant to outliers, right? So they're resistant to influences, they're resistant to effects. So the mean actually is one that gets pulled towards outliers. And what I mean by outliers are any extreme values. So the mean gets pulled towards these outliers. Can't even spell outliers right. So it gets pulled by these outliers. However, the median stays resistant to it, and it maintains its central tendency. Basically, it's able to tell us where the midpoint is a little better, even if there are outliers. So now, let's say we did find the mean and the median. What do they really tell us about the distribution? So, let's say our mean, right? Our mean is pulled by any extreme values. So here we have some extreme values, right? So everything's kind of crowding around this area here, but we end up with extreme values on the right hand side that kind of pull everything a little bit more. So these are our outliers. And which one of those two do you think is going to be the mean or the median? The one on the left or the one on the right? So it's actually going to be the one on the left. And the reason for that is because the median, like we said earlier, is robust or resistant to changes because of these outliers, right? So even though there's these extreme outliers on the right-hand side, and again, I'm referring to these little guys here, right? So these outliers here. There's extreme outliers, but the median maintains its central tendency. So it doesn't actually get pulled towards them as much as the mean would. So the mean is the one that's to the right-hand side. And so, looking at where the mean and the median lie in relation to each other can kind of tell us a little bit about how the distribution is. Whether there's outliers maybe, whether it's skewed a little bit. And so now talking about skewness is essentially where are these outliers pulling everything, right? So even though most of our data is to the left, our outliers are pulling this distribution kind of to the right, right? And so here we have this skewed to the left. I'm sorry, skewed to the right. So even though we have these extreme outliers, what we see happening is that the distribution gets pulled to the right because of these outliers. So we say it's skewed to the right. And so skewness is essentially where are our outliers, where is the data kind of extreme in pulling the distribution. Now let's go ahead and move to the one on the right. So here we have skewed to the, if we had skewed to the left before, this one should be skewed to the right. So now, just so I don't have to remove myself yet. So now, where do you think our mean and median are going to lie? So the median should be the one on the left or the right of those two numbers. It's actually going to be the one to the right. Because again, what happens with the mean? It gets pulled towards, gets influenced by these outliers a lot more, right? And again, these outliers, I'm talking about numbers that are out here, these extreme numbers. So the mean gets pulled towards them. The median maintains its central tendency, so you don't actually ever see it changing too much because of outliers. And then we have the one in the middle, symmetric. So symmetric is essentially, there's not really any outliers in there, and it's distributed symmetrically, just like it says. So it's not really skewed to the left, not skewed to the right. And so what we see happening is that the mean and the median both end up right in the middle. Because the median is the midpoint, and the mean, since there's nothing really extreme on either end, it's kind of split evenly. It's right there in the middle too. So we can see easily that the values of the mean and the median can tell us which one is a better measure of central tendency, and also, looking at just the mean and the median, what does the distribution really look like? So now, what does the result of example 2 tell you about the shape of the distribution? So let's go back to example 2. And what do we get for our mean and median? Example 2, we got the mean is 29.875. And the median was, if I'm not mistaken, 19. Yes. So now our mean is 29.875, our median is 19. So why do you think there's such a big discrepancy between those two? They're supposed to be measured as central tendency, right? So, the mean being a lot bigger than the median, we know that the median is robust, right? So the mean actually got pulled a little further to the right. So what do you think our distribution is going to look like? Skewed to the right, skewed to the left, or symmetric? And I actually just realized something that on the symmetric one, to the right of that we have skewed to the left, not skewed to the right. Can't have skewed to the right twice. So skewed to the left. And so our median is robust. Our mean is on the right hand side, and so the mean is the one that actually gets pulled by these outliers. So our outliers then should be on the right side. So what we end up having is a distribution that is skewed to the right. Because here's our median, here's our mean, it's 19 and 28.75. So that means there's some outliers here. Now looking at the data set, which one of those is outliers? So if we go back to example 2, we see our data set, we have 12, 18, 32, 15, 18, 20, 24, and 100. So which of those do you think is an outlier? Which of those, if more than one, are outliers? It's actually just 100, right? So all these numbers are kind of rolling around 10, 15, 20, 30s, highest, and then we have a random 100, right? So that random 100 is what's happening over here. That's the one that's the outlier. It's the extreme value. It's kind of pulling our mean towards the right, and that's why we end up seeing 28.875 versus 19, because the 19 stays robust, which is the median, and the mean just gets pulled whichever way the outliers are. So, which measure is more appropriate to describe its center? So the center of this distribution, which one is more appropriate, the median or the mean? It's actually going to be the median. Why? So why do you think it's the median? Because our data is skewed, right? So when there's skewed data, our mean doesn't really tell us a measure of center as well, because it just gets pulled which way the outliers are, right? So if there are extreme outliers, the mean's just going to go whichever way the outliers are, but the median is kind of going to stay towards the center of the actual distribution. So when it's skewed, we like to say that you use the median. However, when it's not skewed and it's symmetric, one of the best measures is the mean. So the mean is best when symmetric. I cannot spell today. And that's just about it. So let me go ahead and remove myself so you can see that. And so that's about it for means and medians. And so we kind of get to see where the middle of the distributions lie, how that kind of relates to the distribution itself, and what information we can pull out from a distribution just by looking at the mean and the median. Thanks again, and hopefully we'll see you guys for the next video. Take care.